Hi, everybody. Today we are going to kind of cover two different lessons. We're going to talk about lesson 3.1 and then briefly talk about lesson 3.2 as well. And what our big goal here is today is talking about recursive sequences versus the explicit formulas that we've been talking about before. Because up until this point, we've talked about being able to plug in a specific n value and be able to calculate for the 30th term right away what the value is. Recursive formulas are built using the previous amount in a problem. You need that term before it in order to calculate the next term. So we're going to talk about their usefulness in non-geometric / arithmetic situations, and then how to express geometric and arithmetic sequences recursively. That's a little bit of what we're going to talk about in 3.2. So we are on page 33, and what we're going to talk about here, you're going to want to read through option 1 and option 2, what twins Lester and Maurice have as their options for college and pursuing graduate degrees versus going directly into the workforce. I'm going to have you answer question 1 and question 2. Now, by now, you should see that with Lester choosing option 1 and being given his gift of $35,000 and going on to college, he's starting basically into an account to live off of an amount of $23,500, right? And basically, we want to kind of remember our lovely but the compound interest formula from our previous, hopefully you've seen this before, math classes, in which we're calculating compound interest. Now, notice on the next page here, using this formula, we want to talk about how Maurice is going to get his money. So basically what's happening is he's investing his money into the account, and after month 1, what you're going to see is he's going to take that initial balance, which is $23,500, and he's got an interest rate of 3%, but compounded monthly. So really it's this 0.03 divided by 12. And then he's got $1,000 worth of expenses, though, that he's going to have to take out. So what's happening here is once we type this into the calculator, really what we're seeing is that at the end of that month, his account balance is going to be at $22,558.75, right? And essentially, as we start calculating through, we see these different balances, and each month we can fill these down with that, taking that previous month's balance and starting that as now our new starting balance. So for instance, here we're going to take that 558.75. Remember, with money, you always round to 2 decimal places. And now that's going to be the starting balance that we use to come up with the balance after the next month, right? Now, the nice thing is our calculators can help us out with this, right? So if we start, we have the 23,500, and then 1 plus 0.03 divided by 12 minus 1,000. And what we can do here is we get that balance. We can retype this in, but if you take second negative sign, you kind of shortcut your typing, because we can save that previous answer in our calculator then each time. And what you'll see a little bit quicker here is we can start just hitting enter to get each of the balances. So there's month 2, 3, 4, 5, and we can keep going with this, right? And essentially, this helps us then answer the next question, because each month what's basically happening is, this over, scroll down a little bit, what's happening is we have our starting balance, right? And to get the next month's balance, we're going to take the previous month's balance, so u sub n minus 1, and we're multiplying it by that 1 plus 0.03 divided by 12 and subtracting away the 1,000. Now you also could rewrite this as just 1.0025 just to make your life a little bit easier instead of having to type in all those things each time. But essentially this is what is happening is it's the previous month's balance times 1.025 minus 1,000, right? This is the idea of using a recursive formula because we needed the previous month's balance in order to find our next month's value. Now, the next piece then wants us to continue filling out the rest of this chart. Now, you have a couple options here, okay? You can keep clicking enter 8 bajillion times, or we can use our pal either Google Sheets or Microsoft Excel. And I have these for Excel as well. This is going to actually be the steps to do this in Sheets. So you can follow along. I should have attached this. Hopefully I'll remember to in your email, but basically, or in the link for the video. But essentially what has to happen each time is you're going to want to start by labeling. Makes your life a lot easier if you label. And to start, we're going to type in to the A2 still 0. How we're starting our starting balance month 0. And then we have 1. And the cool thing from here is we can start dragging this down. If we highlight these two cells, I'm going to shift and then down arrow. And once we get these two typed in, if we drag this down all the way to the 26th cell, so we can get 2 years worth of values, here's our months, right? 24 months or 2 years. Okay. Next thing we are going to do is we're going to type in our starting balance for month 0. And the next thing that we are going to do is we are going to type in here equal sign. And then we're going to use kind of that same idea of recursive. We're going to take the previous month's balance, so B2, times, so you're going to have to hit the star, that 1.0025 minus 1,000. We're going to hit enter. And it is going to show us then this next month's balance. Now, to shortcut this and not have to type that in for everything, we're just going to, again, drag down. Oops. Sorry. You're going to want to go on this box, only. Drag down. And it'll fill in for each of those. It'll use that preceding term cell. So we can see after 2 years what our account balance is. Okay, a little bit quicker than typing it into your calculator, maybe. Okay, so if we go back to the notes here, we now have those values. And what, again, this is an example of is an iteration, right? It's that repeated application of the same rule over and over and over again. And we basically get that by the time he graduates, his account is going to be down to $248.47. Okay. Oh, one last thing. In case you ever needed this to be dollar signs, notice this last piece, you would highlight all of this and hit dollar sign. Okay, just to format currency wise. Again, that'll help you with your rounding as well to make it to 2 decimal places. Okay. Now, basically what we are seeing then, if we graph this, here's our graph of all of those account balances, okay? What's basically happening here is that clearly his account is decreasing over time, right? That's what number 8 is asking. So what's going on with this account? It's decreasing, right? He's a college kid, grad school college kid, and he is not making any money, right? But he's getting by. He's down close to 0, however. Now the next question here is this sequence arithmetic, or is it geometric, or is it none of the above? And the answer here, it is neither, right? Because if we try and check these out, the A3 minus A2, if we check out, to look, is there a common ratio? Well, that turns out to be decreasing this amount, but A2 minus A1, we're decreasing this amount. So they don't match, right? And because they don't match, because they're not equal, there is no common difference, right? Same thing with our values. A3 divided by A2 is about 0.958, but A2 divided by A1 is about 959. So again, not equal, there's no common ratio between them. So that's not going to help us. So this is again where recursive comes into play and is very handy for us because we don't have an explicit formula, but we do have a pattern. It's just not arithmetic or geometric, and that's where we can have some use with these recursive formulas. Now, we also have our other brother, right? Lester. And while Maurice is working or in grad school, he went out into the workforce. So basically, what's happening with him didn't quite get as big a gift from mom and dad as Maurice did. Or yeah, as Maurice, but what he's got going on here is that he got a $5,000 gift and he's able to just start saving right away. So he still has the same account balance, but essentially each month he's taking that $5,000, getting that interest rate, but this time he's adding $200 because he's putting some money away. Okay, so same kind of idea in that we have to take the previous month's balance and this time multiplied by that 1.025, but we're going to add $200, right? So as we start calculating here, we can also calculate in here if we want to add in Lester's account balance. And what we can see here, let's make this a little bit bigger, put everything over. Same idea here where we have $5,000 in cell 1. And then here we could say, okay, well, this is going to equal our C2 and then times 1.0025. And then we're going to add 200. And from here, same idea as before, we can fill down to get that. And again, to make sure that we have good rounding on all of this money-wise, we can change this here to hit the dollar signs and see this lovely added in here to get that account balance. So notice in notes, they wanted just up to month 5. And again, you could do this in your calculator as well. Just thought it'd be kind of cool to show you guys how to use Google Sheets. And so at about month 6, he's right here at $6,067.83, right? And notice there is a crossover point in which there is going to be more money in Lester's account than Maurice's account, right? And it's kind of happening here at this intersection in between the two of them. Right about here at the month 17-ish marker, we can month 15-ish marker, we can see that overlap occur and which account has more money. Okay, so essentially what this shows is that the recursive formula does have its place, right? We do need to sometimes have the value of the month or the previous term in order to move on. And this is a good example of that. Well, how does this connect to our lovely arithmetic and geometric things is kind of the next piece of this. And what we're going to see here is when we express things recursively, yes, we want to always take into account two things. What is your starting amount and what is then the pattern? And this is actually going to jump now to the 3-2 notes. If you guys want to flip forward a few pages, we're going to start talking specifically about arithmetic and geometric recursive sequences that are honestly a little bit easier than what we just talked about with Maurice and Lester. So I would definitely get this jotted down. Now notice, and I can't cover this up with my hand, but notice here if we were to take this formula and we covered up this. This is basically what you would need for geometric, right? You're multiplying the previous term each time. And then here, if we covered this up and only covered up the R value, we're adding or subtracting something, a common difference each time, that's arithmetic. If we took this out entirely, then we're back to just being recursive, non-arithmetic, non-geometric if you're using both in a common ratio and a common difference like the Maurice and Lester problems, okay? Now we're going to jump all the way to page 42. Okay, and that's literally all the way to page 42 from here, if you guys are following along to talk. So notice here we have a sequence here, and each time we are doubling, right? So we have this common ratio of 2 happening each time. So to express this recursively, you need to show two things. First of all, what is your first term? Okay, the first term here is 3. We need to include this piece. A lot of times people are going to want to forget that. Don't do that. Okay. And then the next piece here is to say, okay, well, to get my next term, what am I doing each time? Well, I'm multiplying the previous term by 2 each time. This is your recursive formula. Okay. Now, explicitly, though, this goes back to using the formulas we talked about before, where the explicit formula then is going to take the first term times your common ratio to the n minus 1 power. There's your explicit formula. Okay. And finally, to show an arithmetic one, same idea both ways, recursively and explicitly. Well, again, recursively involves writing down your first term. So first term here is 25. And then notice this time we have an arithmetic sequence and we are subtracting 3 each time. So to get the next term, we are going to take the previous term and subtract away 3. There's our recursive sequence. Explicitly from that, we're going to use our formula here. First term plus n minus 1 times that common difference. Distribute and combine like terms. We have negative 3n plus 29 is our explicit formula. Okay. Oops. So there should be a 3 plus 3, so this is 28. There's something to talk about that. All right, so this is, to finish up then, the explicit versus recursive, and we will work more with it in class. Thanks, everybody.